Hello everyone, I am your Kiran Kumar from the Nature of Physics. Today topic is reference circle from the simple harmonic motion. Chapter name is oscillation. For the board exam purpose, I am doing the video for this. A reference circle is giving as a LAQ for AP and TS board exams, IP exams, and full video description I will provide, that is about the displacement, velocity, acceleration of reference circle, and parallelly displacement time graph, velocity time graph, and acceleration time graph, and also equation of the simple harmonic motion. The video link I will provide in the description. Okay student, now this is only for board exam purpose. A body said to be to and fro along the straight line. This is straight line about the mean position is O, such that at any point here P, considering its acceleration is directly proportional to the displacement in magnitude and opposite in direction. So A represent the acceleration of the particle, X represent the displacement of the particle. Here displacement is considering horizontal axis x dash student. OP represent the radius of the circle, and the particle is moving angular velocity omega in anti-clockwise direction. Okay student, so consider a particle P moving in a circle of radius A with angular velocity omega in anti-clockwise direction. Already we discussed. Okay, its position M move on the diameter x dash to and fro, nothing but like this along the x-axis. From the mean position, the particle is doing simple harmonic motion about the mean position. Okay student, one thing you have to notice, in the reference circle the body is moving on the circumference of the circle. It is doing simple harmonic motion on any diameter, but here I am considering x dash diameter student. And also in the definition, the acceleration of the projection of the particle is always directly proportional to the displacement. Here displacement is clearly represented with respect to P position. From the diagram is OM is representing x. Okay student, so for this first displacement linear, then linear velocity, then linear acceleration, and finally we will get the SHM equation student. For this, considering triangle OPM student, so triangle, from this writing cos theta, which is equal to adjacent side is OM divided by hypotenuse is OP, so that is equal to x divided by A. A is cross multiplication, so that I am getting here x is equal to A cos theta student. And also continuation, next step is omega is the angular velocity, so that angular velocity, the rate of change of angular displacement is called angular velocity. Omega is equal to theta divided by t. From this equation, angular displacement theta is equal to omega t, writing theta is the angular displacement. Okay student, the value of theta is replacing in the displacement equation. I am getting here x, which is equal to A cos, instead of theta I am writing omega t, is equation number 1 student. Here A represent amplitude and omega represent angular velocity, represent time. Here at particular position t representing time student, and theta representing angular displacement. Okay, next I am going to discuss about the linear velocity V student. The rate of change of linear displacement is called a linear velocity. Here I am writing we have a space in which linear velocity V, which is equal to dx divided by dt. Rate of change of linear displacement is called linear velocity. Already we have a displacement equation, x is equal to A cos omega t. Equation 1 is replacing in this equation, then we will get the velocity. So that linear velocity basic equation writing V, which is equal to d by dt of x student, x value is replacing. Otherwise, one more step I wanted to write here x, and then continuation here V, which is equal to d by dt of x value. From the equation 1 I am writing A cos omega t student. Okay, so that velocity V, which is equal to A common, so d by dt of cos omega t, and next step velocity v is equal to a into cos omega t become minus sin omega t, and differentiation with respect to time only, but here omega t is there, that's why omega is constant and common writing like this. So finally I got the velocity v which is equal to minus a omega sin omega t. This is equation number 2. After the first differentiation, rate of change of displacement is called velocity. We got the linear velocity equation. Then I am going to write the acceleration, student. For acceleration, basic equation writing a which is equal to dv divided by dt. Rate of change of linear velocity is called linear acceleration. So that linear acceleration a which is equal to d by dt of velocity equation is replacing. Now we got the velocity minus a omega sin omega t, that is from equation number 2. Okay student, a omega is common, so minus a omega common writing d by dt of sin omega t. Okay student, for sin omega t, differentiation of sin omega t become cos omega t, but omega is common because of differentiation with respect to time only. So that a which is equal to minus a into omega cos omega t, student. Okay, a which is equal to minus a into omega is omega square cos omega t. This is I can write as equation number 3, student. In this equation is modified. So acceleration equation a which is equal to minus omega square into a cos omega t, student, from equation number 1. Okay, so that a cos omega t which is equal to x, student. So that a which is equal to minus omega square x writing here. This is I can write as equation number 4. So that in this equation the acceleration is directly proportional to the displacement in magnitude and opposite in direction. This equation is written as equation 5. Equation 5 represent the simple harmonic motion. This is representing simple harmonic motion of a reference circle, student. A reference circle. Okay, please do like and subscribe for more videos.